So now that we've learned about our different electrical components, we need to start thinking about how we can attach them all together to create custom circuits. Now, traditionally, these types of components would be soldered together to make a permanent lasting connection. Anything that's put into a computer or a phone is soldered, and basically when we solder things, we take metal and we use it and we melt it and we use it to permanently fuse different components together. We could do this. This is actually a relatively simple and inexpensive thing for us to do. However, if we ever want to tweak things, it makes it difficult to disassemble some of the circuits that we create. And if we are able to get them apart, sometimes it comes apart pretty sloppily, so we can't reuse things. And for that reason, we're going to be using something else. So this right here is called a breadboard. You guys have a picture of this as part of the sheet that you're filling out. And yours is turned vertically, so I'm going to refer to things the way that you would be looking at them, so imagine that this video is turned sideways. Now when we're looking at a breadboard, it's very similar. It's kind of, we call it a solderless connector for circuits. So on the front, on the very top, we see that there's all these labeled rows and columns, and there's plastic ports and things like that. If you were to put metal into any of these ports, it's going to connect with metal plates that are underneath on the inside that we can't see. These are also relatively inexpensive, which makes them nice for prototyping because you can easily pop things in and out. Now I'm going to use 4 colors to label this, and I'm going to have you guys do it along with me. So we're going to start first with red. Now you'll see on either side that there are red and blue indicators, and there's lines that go with them. They're showing us already what metal components are underneath in the breadboard. So if we were to look at the one on the very top, for you guys it's the very left, you see that it's marked positive. And that is one single metal piece that is underneath all 15 of those holes. Now the idea behind this is that this is where your power supply would go. So this is where your hot end would go. In electronics, and this is kind of a long story short, people mistakenly thought that electrons flowed positive to negative, which is why they still refer to positive as your energy source, even though it's technically negative electrons that are flowing through. So that's just why it's marked positive. But we've got one on each side. And what I could do is run a power line into any of these ports, and it's going to electrify this entire metal piece here, this entire red metal piece. Now we've got these blue ones. These are our grounds, or our neutrals. These are what are going to complete our circuits. So these are likewise a single piece of metal, one here and one here. Now none of these touch each other, which means that I could electrify half of my breadboard. I could do the whole thing if I wanted to. But it's going to allow me to then run this electricity supply to any of these holes if I want to. I'm going to erase those lines right there. I'm going to switch to green and start taking a look at what's in the middle of this breadboard. Now, we have 10 columns. We have A, B, C, D, E on one side. We have F, G, H, I, and J on the other side. And we have 30 rows on each side. There's actually 60 individual metal pieces within these two sections. So they don't touch, they don't cross. There's kind of a divider in the middle here. So we've got 30 on the left and we've got 30 on the right. I'm going to go ahead and start drawing where the metal is. They run by these numbered rows, kind of like in a spreadsheet almost. So I'm going to have you start filling these in too. I'm going to go all the way down through 30. And basically what happens is I could run, I'm going to use black to show, I could run power from any of these red highlighted ports to any of these ones. And if I do that, I'm now carrying electricity from the red hot supply to, for in this example, row number 6. And all 5 of these ports for number 6 will now start to carry electricity because they are metal, so they are conductors of electricity. That gives me the ability to plug 4 other things onto row 6 if I want to, and then I can use those to create custom circuits. On the other side, I'm going to use yellow, we've got F, G, H, I, and J. It's just another 30 rows. Now what we're going to take a look at on the next slide is how we can use these ports and use kind of like bridges almost to allow electricity to bounce from one to the next to create a closed circuit. Okay, so let's go ahead and try to actually build a circuit using the breadboard. We're going to try to do a very simple series circuit where we light an LED light bulb. Now we know from our previous videos that LEDs don't handle a lot of electricity, so we have to couple them with a resistor. So I've got my LED right here. We're going to go ahead and drag this onto our breadboard. I'm just going to, how about 17 and 18? You could put this on any rows you wanted to, but assume that those metal prongs go into the actual holes and make contact with the metal behind the breadboard. Got this little resistor over here. The picture isn't that great, so I lost the metal ends, so I'm going to have to manually draw them on. I'm going to go ahead and use my red to show you the power supply. Remember that we always try to mark that with a red wire so we know which one is supplying the electricity. And then we're going to go ahead and add that to the breadboard here. Now what that's going to do is electrify this entire strip right here, because the power is going to end up carrying along all of the metal because it will conduct it consistently or evenly. I'm going to go ahead and erase this line though, just so that way we can see everything else. From there, I'm going to have to jump my electricity, and I can use any of those 15 holes that, or I guess the 14 remaining ones that are on that strip. I'm going to go ahead and put it on, how about, let's say 5. So we're going to go ahead and plug that into 5. What this does now is allows the electricity to flow from our power source along the metal conductor over to row 5, and it's going to activate or turn on kind of all of the power on circuit 5. So the metal piece that runs behind 5 is now carrying electricity as well. Our resistor is going to then plug into the 5th row. So I'm going to draw this line, and it's going to just connect into any of the ports on 5. And we need to make it connect to 17. And when I do that, the resistor acts kind of like a bridge. The electricity will go from 5 through the resistor. It's going to be reduced, because that's what resistors do. It's going to end up in row 17. Now 17 is active. From there, the power goes up into the diode, up that metal prong into the diode. It's going to activate the light. It's going to come back down into row 18, which then is going to then provide power to strip 18. And from there, I need to use one more jumper wire to connect it back to one of these side strips. So on 18, doesn't matter which port I'm in, I'm going to connect it to the blue. That's not a very well drawn one. To a port on this blue line, and then I'm going to connect the blue line to the neutral of my power source. So that'd be the other part to complete the circuit. So I'm going to show you with my yellow how power would flow through this circuit. So electricity is going to come from our power source through the red line. It's going to activate, or it's going to be conducted through this entire metal strip, because the red line is touching and making contact with that strip. From there, I can use any of these 14 ports to carry the electricity over into row 5. So it's going to turn on row 5. Going to be picked up by our resistor, travel through our resistor to row 17. This LED is going to take the electricity up through the bulb, turn on the light, hey, we have a light. And then it's going to come down through the other prong to activate row 18. I connect a wire from 18 to the blue strip, so now this is going to carry through the blue strip, which then means it can go along this black wire back towards the source, and we've created a closed circuit. We're going to go ahead and try this out now. I'm going to show you how this would actually work using real materials, and then you're going to build one yourself.